All right, so all the familiar limit laws hold, sums, differences, products, quotients, etc., including the squeeze theorem. And so I thought I would do an example with you and show you how you can work this out. So I want to actually compute this limit. And unlike the last example, we want to show that it actually does exist and compute it, which means we either have to check infinitely many paths, which is not really possible, or we need to somehow make use of something else. And so we're going to try and use the squeeze theorem here. A couple of key things that I want you to realize is that hopefully it's clear to you that x squared is less than or equal to x squared plus y squared, because unless y is 0, y squared is bigger, and so this inequality holds. And so that tells me that, well, I can divide and I can get x squared. Here, let's actually write it down here so that there's a little bit more room. So I get that x squared over x squared plus y squared is always less than or equal to 1. That's important. We're going to need that little observation. Okay, so what I want us to realize, that's the first sort of useful observation. The other observation that I want us to realize is that anytime any number, let's just use y, is always less than or equal to its absolute value and greater than or equal to negative its absolute value. And so it's one of these is going to be equals, by the way. If, for example, if y is 5, then y equals absolute value of y and is greater than negative 5, right? So 5 equals the absolute value of 5, which is 5, and is greater than negative 5. So this is always true. So I'm going to start with this observation, and I'm just going to go ahead and realize that I can multiply by this other piece that I want. This is always positive. So I'm going to multiply all three parts of this inequality by 3x squared over x squared plus y squared. And so that's going to lead me to the following inequalities. And so I get minus 3x squared absolute value of y over x squared plus y squared. That's less than or equal to 3x squared y over x squared plus y squared. That's less than or equal to 3x squared absolute value of y over x squared plus y squared. I'm going to need some more room, so let's just drop this down a little bit. There we go. Okay, so now what I want you to realize is that x squared over x squared plus y squared is less than or equal to 1. So this whole piece is less than or equal to 3 absolute value of y. And on this side, now I want to compare the left side with, I'm interested in minus 3 absolute value of y. But think about it. This part is less than or equal to 1, and so when you throw in the negative, it's actually bigger. And so in this particular situation, I get the following realm of inequality, string of inequality, excuse me. And so now I realize that as xy goes to 0, this goes to 0, and this goes to 0, and so that forces the inside piece to go to 0. So we can say, so since the limit as xy goes to 0, 0 of minus 3 absolute value of y is the limit as xy goes to 0, 0 of 3 absolute value of y is 0, the squeeze theorem implies that the limit that we want, the limit as xy goes to 0, 0 of 3x squared over x squared plus y squared, this guy is 0, 2. So let's break this video here. In the next video, we'll talk a little bit about continuity.